everyone, welcome back to my channel. In this video, we are going to study about linear Diophantine equation. First, let us understand the definition of linear Diophantine equation. An equation of the form ax plus by which is equal to c, where a not equal to 0 and b not equal to 0 and c is an integer is called a linear Diophantine equation of two variables x and y. Here, x and y are unknown variables. So, this is a definition of linear Diophantine equation. That is, any equation of the form ax plus by which is equal to c is called linear Diophantine equation of two variables x and y. Here a and b are not equal to 0 and c is an integer. So this is a definition of linear Diophantine equation. This is very important concept. It is based on Euclid's algorithm, which is already discussed in a previous video. You can check the video link in the description. Next we shall see important theorem on linear Diophantine equation. It states that if a comma b which is equal to d, that is GCD of a comma b which is equal to d, then the linear Diophantine equation ax plus by which is equal to c has a solution if and only if d divides c. Here with the condition GCD of a comma b which is equal to d, we have to show that the linear Diophantine equation ax plus by which is equal to c has a solution if and only if d divides c. Here the condition if and only if means we have to prove this statement in both the methods. That is, we have to prove that if the linear Diophantine equation has a solution, we have to prove that d divides c, as well as if d divides c, we have to show that the linear Diophantine equation ax plus by which is equal to c has a solution. Let's see how to prove this theorem. First, I am considering d divides c. Here I am considering first d divides c, and we are showing the linear Diophantine equation ax plus by which is equal to c has a solution. Here we are considering d divides c, that is, if d divides c, which implies c is equal to d into x, where x is an integer. This is because by the definition of divisibility, if d divides c, we can write in the form as c which is equal to d into some integer x. Call this as equation number 1. Also, we have to consider the condition, that is GCD of a comma b which is equal to d, that is given in the statement. Since the GCD of a comma b which is equal to d, there exists an integer x1 and y1 such that ax1 plus by1 which is equal to d. This statement holds because by the definition of Euclid's algorithm, here if any GCD of any two integer which is equal to d, then there exists an integer x1 and y1 such that we can write an equation of the form ax1 plus by1 which is equal to d. This is a definition of Euclid's algorithm. Here take this equation as equation number 2. Multiplying this equation 2 by c by d, we get, here if we multiply in this equation 2 by c by d, we get, here equation 2 is this, if you multiply by c by d, we get a equation as a into c by d into x1 plus b into c by d into y1 which is equal to d into c by d. Here we have to multiply throughout the equation by c by d, we get an equation like this. Here dd gets cancelled, the remaining is a into c by d x1 plus b into c by d y1 which is equal to c. Here we cancel these d values, the remaining is a into c by d into x1 plus b into c by d into y1 which is equal to c, which implies a into x0 plus b into y0 which is equal to c. Here take this value as x0 and take this value as y0, we get as ax0 plus by0 which is equal to c, where x0 is c by d into x1 and y0 is c by d into y1 are the solution of a linear Diophantine equation. Here if we do this procedure, we get an equation of the form ax0 plus by0 which is equal to c, where x0 is c by d into x1 and y0 is c by d into y1, which is the solution for a linear Diophantine equation. Here we are considering d divides c and we are showing the linear Diophantine equation as a solution. Next we have to prove conversely. First we have to consider, suppose linear Diophantine equation ax plus by which is equal to c has a solution, say some x0 and y0, we have to show that d divides c. Here linear Diophantine equation has a solution, say x0 comma y0, which implies ax0 plus by0 which is equal to c. Call this equation as equation number 3. Also we have to prove that the d divides c. To show that d divides c, we have to take the condition also, that is, we know that GCD of a comma b which is equal to d, this is given in a statement itself. Here GCD of a comma b which is equal to d, or we can take this value as d divides a and d divides p. This is because by the definition of GCD GCD. Here GCD of A comma B, which is equal to D, which implies that D divides A and D divides B. Here D divides A and D divides B. By the divisibility condition, we can take it as A is equal to D into R and B is equal to D into S, where R and S are integers. So we know that the GCD of A comma B, which is equal to D, we can take this value as D divides A and D divides B. This value obtained by the definition of greatest common divisor. If D divides A and D divides B, we can write it as A is equal to D into R and B is equal to D into S. This is because of the definition of divisibility. These are all the values discussed in a previous videos. Next, A is equal to D into R and B is equal to D into S. Substituting this A and B value in equation number 3, here we have to substitute in the place of A and B as D into R and D into S, we get as D into R into X naught plus D into S into Y naught, which is equal to C. Here in these two, take D as common, we get as D into R X naught plus S Y naught, which is equal to C. So this is of the form A into D into R. Here this is of the form D into some integer, which is equal to C. So we can conclude this implies D divides C. Here if D divides C, we can take it as C, which is equal to D into some integer. We know that R is integer, S is also an integer, X naught and Y naught is also an integer. So we can write D into R X naught plus S Y naught, which is equal to C, is same as that of D divides C. Here we are considering linear Diophantine equation as a solution and we are proving D divides C. So this completes the proof. First we considered D divides C and we proved linear Diophantine equation as a solution. Conversely, we are considered linear Diophantine equation as a solution and we proved D divides C. So both the conditions satisfied. This completes the proof. Next we shall see working rule to find linear Diophantine equation. First, the linear Diophantine equation is of the form Ax plus By, which is equal to C. Here they give a problem which is of the form Ax plus By, which is equal to C. First step, we have to find GCD of A comma B. That is, we first find A comma B, which is equal to D. That is GCD of A comma B. Next step, we have to verify that if D divides C or not. Here they will give an equation of the form Ax plus By, which is equal to C. First, we have to find the GCD for this value. We get an GCD value as D. Next we have to verify that GCD value divides this C value. If the D does not divide C, then the given equation has no solution. Here we can conclude if D does not divide C means the given equation has no solution. Next step, if D divides C, then find a particular solution for Ax plus By, which is equal to C. Here if D divides C, then we have to find the particular solution for this linear Diophantine equation, that is Ax plus By, which is equal to C, by finding that to find X naught and Y naught value by Euclid's algorithm method such that Ax plus By, which is equal to D. Here we have to find the particular solution with the help of Euclid algorithm. That means we have to find X naught and Y naught value with the help of Euclid algorithm. Next step, after finding X naught Y naught value with the help of Euclid algorithm, the general solution is given by the formula X is equal to X naught minus B by D into M and Y is equal to Y naught plus A by D into M, where M is an integer. So this is a working procedure to find a linear Diophantine equation. Let's see some of the problems so that you can understand in a better way. Here is a first problem. Solve the linear Diophantine equation of 2x plus 4y, which is equal to 21 for all x comma y belongs to integer z. Here they were given linear Diophantine equation of the form Ax plus By, which is equal to C. So first take the given data. Given equation is of the form Ax plus By, which is equal to C, where here we know that A value is 2 and B value is 4 and C is 21. What's the first step? Here we have to find the GCD for A and B. Here A is 2 and B is 4. So we have to find the GCD of 2 and 4 first. Here finding the greatest common divisor value, we are already discussed in a previous video how to find the GCD for any two integers. Here first you have to take the division value. That means we have to divide this 4 with the help of 2. Take like this. Here we have to apply simple multiplication table over here. Here we know that 2 into 2 is 4. We can easily find that is 2 into here quotient is 2. 2 into 2 is 4. We have to subtract this 4 by 4. We get a value as 0. Therefore, we can conclude that the last non-zero remainder is a GCD. Hence, we can take the GCD of A comma B, that is 2 comma 4 is 2. After finding the GCD value, next we have to observe if this GCD value divides the value C. Clearly, we know that 2 does not divide 21. We already know 2 does not divide 21. That is because we cannot write 2 divides 21 in the form of 21 which is equal to 2 2 into some integer. So we can easily say 2 does not divide 21. Since the D value does not divide C, we can conclude that the equation, that is 2x plus 4y, which is equal to 21, has no solution. This completes the problem. Here we have to take a linear Diophantine equation and find the value of A, B, C. Next we have to find the GCD value. After finding the GCD value, first step we have to verify that the condition D divides C holds or not. If D does not divide C, we can conclude that the given equation has no solution. If D divides C, the procedure is different. Let's see some more problems. Here is the next problem. Solve the linear Diophantine equation of 5x plus 3y, which is equal to 4 for all x belongs to integer z. Here the given equation is of the form ax plus by, which is equal to c. Therefore, this is a linear Diophantine equation. Therefore, here A value is 5, B value is 3 and C value is 4. Next, we have to find the GCD for A comma B, that is 5 and 3. We have to find the GCD of 5 and 3. Here, we have to divide this 5 with 3. Therefore, consider like this. We have to divide this 5 value with 3. Here 5 is a dividend and 3 is a divisor. Here we have to find the quotient value. Here we know that 3 into 2 is 6, which is greater than 5. Consider less value, that is 3 into 1 is 3. We have to subtract 5 by 3. We get a value as 5 minus 3 is 2. So 2 is a remainder. Here 5 is dividend, 3 is divisor, 1 is quotient and 2 is a remainder. Next step, we have to divide this divisor value with the remainder. So take like this. We have to divide 3 by 2. Here we know that 2 into 1 is 2. Next step we have to subtract 3 by 2. We get a value as 1. So 1 is a remainder. Next step we have to divide this divisor by 1. So take like this. We have to divide 2 by 1. We know that 1 into 2 is 2. Here 2 minus 2 is 0. Therefore we have to stop a division method here. Next step we have to find the GCD, means GCD is nothing but the last non-zero remainder in a division is a GCD value. Here we have to stop this division method when we get a remainder value as 0. So this previous to this value, this is a last non-zero remainder. Therefore we can conclude that GCD, which is equal to 1, because this is a last non-zero remainder. Hence we can conclude that the GCD of 5 and 3 is 1. This procedure completed, that is finding GCD value is completed. Next we have to verify that D divides C or not. Here the GCD of 5 and 3 is 1. So this is the value of D, and we have to verify that D divides C, that is C is 4. So D divides C is nothing but 1 divides 4. We know that 1 divides 4. We can take this as 4 is equal to 1 into 4. So we can conclude that 1 divides 4. So this condition verifies. Therefore, the equation has a solution. This is the first step, that is first we have to find the GCD. Using the GCD value, we have to verify that D divides C or not. If D does not divide C, means the equation has no solution. If D divides C, the equation has a solution. Next step, we have to find the particular solution for this given equation. That is to find the particular solution for 5x plus 3y, which is equal to 4. Here to find the particular solution means you have to apply division algorithm method over here. Using division algorithm method, this division method gives a value like this. That is, we can write it as 5 is equal to 3 into 1 plus 2. By division algorithm method, we have to write the dividend value as divisor into quotient plus remainder. So that is division algorithm method. So with the help of division algorithm method, we can write it as dividend is 5, which is equal to divisor is 3 into quotient is 1 plus remainder is 2. In the similar way, we have to take the division algorithm method for this. Here 5 is equal to 3 into 1 plus 2, or we can take this value 2 as 5 minus, here take this value to the left hand side, we get as 5 minus 3 into 1. Call this as equation number 1. Next we have to find the division algorithm method for this value also. That is, we get a value as 3, which is equal to 2 into 1 plus 1, or we can take this as 1, which is equal to 3 minus 2 into 1. Call this as equation number 2. Here no need to take this division algorithm method for this value, since the remainder is 0 here. To find the particular solution for the given linear Diophantine equation, we have to use division algorithm method for this fraction. Next step, take this equation number 2. From equation 2, we have 1 is equal to 3 minus 2 into 1. We have to substitute in the place of 2 as 5 minus 3 into 1. So consider equation 2 and substitute 2 value with the help of equation number 1. It is 1, which is equal to 3 minus, here we know that 2 is 5 minus 3 into 1 into 1. Next time multiply 1 inside the bracket, we get as 3 minus 5 into 1. Here minus 2 minus plus 3 into 1. Here we have 3 into 1. Here also we have 3 into 1. If we add this value, we get as 1, which is equal to 3 into 1 plus 1 minus 5 into 1. Here we know that 1 plus 1 is 2. So take the equation as 1, which is equal to 3 into 2 minus 5 into 1. Here taking this equation, next step we have to multiply throughout the equation by 4. Because to obtain an equation is of the form 5x plus 3y, which is equal to 4. That is linear Diophantine equation. Here in the place of c, here we have 1, but c value is 4. So to achieve that c value, we have to multiply throughout the equation by 4. We get the equation as 4, which is equal to, here in the right hand side, the equation is of the form 5x plus 3y, which is equal to 4. That is, to achieve that equation type, we have to multiply 4 by 2 and we have to multiply 4 with 1. We get as 3 into 4 into 2 is 8 minus 5 into 4 into 1 is 4. Here if we multiply 4 for this, we cannot get an equation of the form 5x plus 3y, which is equal to 4. So to obtain a linear Diophantine equation, we have to multiply throughout the equation. We have to multiply the values for this, the not for 3, and here also we have to multiply the value 4 for 1, not for 5. So we get a equation is like this. Next step, we can take this as 4, which is equal to, here multiply minus inside the bracket, we get as 5 into minus 4 plus 3 into 8. So we can conclude this is of the form 5x naught plus 3y naught. Therefore, we can take this value as 5x naught plus 3y naught, where x naught value is minus 4. Here comparing this to equation, x naught is minus 4 and y naught is 8. So this is a particular solution for a linear Diophantine equation. Here we have already discussed the statement, that is, if D divides C statement holds, we can take the linear Diophantine equation as a solution. We get a value as x naught and y naught. So we get an equation is of the form 5x naught plus 3y naught, where x naught is minus 4, y naught is 8. So this is a particular solution for a given linear Diophantine equation. Also, next step we have to find a general solution for the linear Diophantine equation, which is given by the formula x is equal to x naught minus b by d into m and y is equal to y naught plus a by d into m, where m is some integer. So substituting b value, a value and d value, also x naught and y naught value, we get a general solution as, that is, x is equal to, here we know that x naught is minus 4 minus, here b is, we know that b value is 3 and d value as, d is nothing but gcd, d value is 1 into m as it is. Also y is, here y naught is 8 plus a value is 5 divided by d is 1 into m is as it is. So we can take this as x is equal to, here minus 4, here 3 by 1 is 3 itself. So we can take it as minus 4 minus 3m and y as 8 plus 5m. Therefore, we can conclude finally as x is equal to minus 3 minus 4 and y is equal to 5m plus 8 for all m belongs to z is a general solution for a linear Diophantine equation. So this is a procedure to find a linear Diophantine equation. Next we shall see some more problems so that you can understand in a better way. Understand carefully, these are all very important problems, that is linear Diophantine finding or solving the linear Diophantine equation problems are very important problem. They will ask in examination. Next problem, here solve the linear Diophantine equation of 20x plus 16y, which is equal to 500 for all x belongs to z. Here we have to take the given equation. Here we know that the given equation is of the form ax plus by, which is equal to c, where a value is 20 and b value is 16 and c is 500. Here comparing this to equation, we get a abc value like this. Once we find abc value, next we have to find the GCD for a and b. Here a is 20 and 16, b is b. So we have to find the GCD of 20 and 16. That is nothing but we have to divide 20, that is greater value with a smaller value. So we have to divide 20 by 16. Here 20 is a dividend, 16 is a divisor. Here quotient we get a value as, if we multiply 16 into 1, we get a value of 16. If we take a quotient value as 2, we get a 16 into 2 as 32, which is greater than 20. So take a lesser value which is equal to 20 or less than 20. So we get a quotient value as 1. That is 16 into 1 is 16. Next step we have to subtract 20 by 16. We get a value as 4. So 20 minus 16 is 4. This is a remainder. Here 1 is quotient, 4 is a remainder, 16 is divisor and 20 is dividend. Next step we have to divide the divisor value with the remainder. So we have to take like this. We have to divide 16 by 4. We know that 4 into 4. 4 into 4 is 16. Here 16 minus 16 we get a value as 0. Here we have to stop the division method here. Next we have to consider the last non-zero remainder as a GCD. that is GCD, which is equal to 4. This is because the last non-zero remainder is nothing but a GCD. Therefore, we can conclude that the GCD of 20 and 16 is 4. Also, we have to verify the condition, that is D divides C or not. Here D is nothing but 4 and C is 500. Clearly we know that 4 divides 500. Therefore we can conclude that the GCD of 20 and 16 is 4 and 4 divides 500. This shows that the equation, that is 20x plus 16y, which is equal to 500, has a solution. Once the equation has a solution means we have to find a particular solution. Finally we have to find the general solution. Next step, to find the particular solution for 20x plus 16y, which is equal to 500, we have to use division algorithm method. Here first take the division algorithm method. For this fraction we get as dividend, which is equal to divisor into quotient plus remainder. Here dividend is 20, which is equal to divisor is 16 into quotient is 1 plus remainder is 4. Or we can take this as 4 is equal to, we take this value to the left hand side, we get as 20 minus 16 into 1. Since the remainder is 0 here, no need to take a division algorithm method for this value. Take the division algorithm method for this value, we get a value as 4 is equal to 20 minus 16 into 1. This of the form 4 is equal to 20 into 1. Here take minus inside the bracket, we get as 20 into 1 plus 16 into minus 1. Next step, to obtain a linear Diophantine equation of the form 20x plus 16y, which is equal to 500. Here we have 4, so we have to multiply throughout the equation by 125. So for this equation, you have to multiply throughout the equation by 125. We get as 4 into 125, which is equal to 20 into 125 plus 16 into minus 125. Here this is a very important step, that is we have to multiply the value so that we get a value as same as that of C value, and the equation obtained must be of linear Diophantine equation. So this is very important step. Here 4 into 125 is 500, which is equal to 20 into 125 plus 16 into minus 125. So this is of the form 20x0 plus 16y0, where x0 value is 125 and y0 value is minus 125. Therefore we get a x0 and y0 value, so which is a particular solution for a given linear Diophantine equation. So this is a procedure to find a particular solution. Next, after obtaining particular solution value, that is x0 and y0 value, next you have to find the general solution. That is general solution is given by the formula x is equal to x0 minus b by d into m and y is equal to y0 plus a by d into m, where m belongs to z. So this formula you have to remember. Substituting x0, y0 value, a, b and d value, we get as x is equal to, here x0 is 125 minus b is 16 divided by d value is nothing but GCD value, that is 4 into m, and y is, here y0 is minus 125 plus a is 20 divided by d is 4 into m. Here 4 ones are 4 fours are, here also 4 ones are 4 fives are, we get a value as x is equal to 125 minus 4m and y is equal to minus 125 plus 5m. Therefore we can conclude that x is equal to minus 4m plus 125 and y is equal to plus 5m minus 125 for all m belongs to z is the general solution for a given linear Diophantine equation. This completes the problem. We shall move on to another problem. Solve the linear Diophantine equation of 39x minus 56y, which is equal to 11 for all x belongs to z. Comparing these two equations, we get a value of a as 39 and b is minus 56 and c value is 11. Next step, we have to find the value of GCD for a and b. Here a is 39 and b is minus 56. Here we can't find a value for negative value, that is we have to find the GCD of 39 and minus 56 is not possible. So we have to find the GCD for 39 and plus 56. This is because we have to know that the GCD of a comma b, which is equal to d, is same as that of GCD of a comma minus b, or we can take it as minus a comma b or for minus a comma minus b. Here GCD for negative value, here if we take this as minus a comma minus b, which is equal to some value, that we can take this value as same as that of a comma b. This is because minus a comma minus b, which is equal to d, which is implies d divides minus a also and d divides minus b also. Therefore we have to find the GCD of negative value is same as that of, we have to take that value as positive and we have to find the GCD for that value. So here we have 39 and minus 56. So we have to find the GCD for 39 and plus 56. For that, here we have to divide the highest number, that is 56 by 39. Here we know that 39 into 1 is 39. Next we have to subtract 56 by 39. We get a value as 17. If you subtract 56 by 39, we get as 17. This is a remainder. 1 is a quotient. 39 is a divisor. 56 is dividend. Next step, we have to divide the divisor value with the remainder value. So we have to take like this. You have to divide 39 by 17. So we get the quotient value as 2. We know that 17 into 2 is 34. Next step, we have to subtract 39 by 34. We get a value as 5. This is the remainder value. Next step, we have to divide the divisor value 17 with the remainder 5. So we get 5 into 3. So 3 is a quotient. So 5 into 3 is 15. Next step, we have to subtract 17 by 15. We get a value as 2. This is the remainder. Next step, we have to divide the divisor value by the remainder. So we have to take like this. We have to divide 5 by 2. You know that 2 into 2 as 4. Next step, subtract 5 by 4. We get as 1 as a remainder. Next step, we have to divide this divisor value 2 by 1. We get a quotient value as here 1 into 2 is 2. Therefore, we get 2 minus 2 value as 0. So, we get a value 0. We have to stop the division method here. Finally, we can conclude that the last non-zero remainder. Here, the last non-zero remainder is 1. Therefore, we can conclude that GCD is 1. Therefore, the GCD is 1. This is because the last non-zero remainder in the successive division is nothing but the greatest common divisor value. Therefore, we can conclude GCD is 1, or we can take it as GCD of 39, 56 is 1. Next, we have to verify the GCD value divides the value C. That is, also we have to verify the condition D divides C or not. GCD of 39 and 56 is 1. That's the value of D. We know that the value D, that is 1 divides 11. Next step, we have to find the particular solution for the linear Diophantine equation, that is 39x minus 56y, which is equal to 11. So to find a particular solution means you have to use division algorithm method over here. Here first take a division algorithm method for this fraction. We get as 56, which is equal to 39 into 1 plus 17. This is a division algorithm value. Or we can take this as 17, which is equal to, take this value to the left hand side, we get as 56 minus 39 into 1. Call this as equation number 1. Similarly, apply division algorithm method for this value. We get as 39, which is equal to 17 into 2 plus 5. Or we can take this as 5, which is equal to, take this value to the left hand side, we get as 39 minus 17 into 2. And call this as equation number 2. Also, apply division algorithm method for this fraction. We get as dividend, which is equal to divisor into quotient plus remainder, that is 17 is equal to 5 into 3 plus 2. Or they take this 2 value as, here take this value to the left hand side, we get as 17 minus 5 into 3. Call this as equation number 3. Similarly, for this division algorithm method, as 5 is equal to 2 into 2 plus 1. Or we can take 1 is equal to, take this value to the left hand side, we get as 5 minus 2 into 2. Call this as equation number 4. Here no need to take the division algorithm method for this function because the remainder is 0 here. Next step, take the equation 4 and apply in the place of 2 as this equation number 3, and in the place of 5 as equation number 2, and in the place of 17 as equation number 1. We get as, from equation 4, here take the equation 4 as 1 is equal to 5 minus 2 into 2. Next step, substitute in the place of 2 as equation number 3. Here substituting equation number 3 in the value 2, we get as 1 is equal to 5 minus, here 2 is nothing but 17 minus 5 into 3 into 2 as it is. Next step, multiply 2 inside the bracket, we get a value as 5 minus, here 2 into 17, here minus 2 minus plus 5 into, here 3 into 2 is 6. Here we know that, here we have 5 into 1, here also we have 5 into 6, so we have to add this value, we get as 5 into 1 plus 5 into 6 is 5 into 7 minus 2 into 17 as it is. Next step, we have to substitute in the place of 5, that is from equation 2, substituting 5 value over here, we get as, here 5 is nothing but 39 minus 17 into 2 into 7 as it is, minus 2 into 17 as it is. Multiply 7 inside the bracket, we get as 39 into 7 minus 17 into, here 2 into 7 is 14 minus 2 into 17 as it is. Here we have minus 17 into 14, here we have minus 17 into 2. So we have to add this value, we get as 39 into 7 as it is. Here if we take minus sign common, we get as 17 into 14 plus 2. We know that 14 plus 2 is 16. Therefore, we get minus 17 into 16. Next step, substituting the value here 17 That is, from equation 1 we have here 39 into 7 as it is, minus here 17 is nothing but 56 minus 39 into 1 into 16 as it is. Next step, multiply 16 inside the bracket we get as 39 into 7 minus here 56 into 16 minus 2 minus plus 39 into 16 into 1 is 60. Here we have 39 into 7, here we have 39 into 16. If we add those value we get as 39 into 23 minus 56 into 60. That is the value of 1. Next step, to obtain a linear Diophantine equation. So to obtain C value, here we have C value is 1. In the given problem, the equation is of the form 39x minus 56y is equal to 11. So to obtain that value, we have to multiply throughout the equation by 11 here. We get here 1 into 11 is 11, which is equal to 39 into 23 into 11 minus 56 into 16 into 11. Here in the right hand side, to achieve a linear Diophantine equation, we have to multiply 11 inside the bracket for this 23 and for 16. We get a value as 11 is equal to 39 into here 23 into 11 is 153 minus 56 into 16 into 11 is 176. So this is same as that of 39x0 minus 56y0. So this is a solution for a linear Diophantine equation with x0 value is equal to 253 and y0 value is 176. So this is a particular solution for the given linear Diophantine equation. Next, we have to find the general solution for the linear Diophantine equation. For that, the formula is x is equal to x0 minus b by d into m and y is equal to y0 plus a by d into m, where m is some integer. So substituting x0 value, y0 value, a, b and gcd value we get as here x is equal to x0 is 253 minus b value is minus 56. So we have to apply b value here, that is b is minus 56 divided by gcd is 1 into m. Similarly, y is equal to y0 is 176 plus so a value is 39 divided by gcd is b is equal to 1 into m. So multiply minus inside the bracket we get a value as x is equal to 253 here minus 2 minus plus 56m and y is 176 plus 39m. Therefore, we can conclude that x is equal to 56m plus 253 and y is equal to 39m plus 176 for all m belongs to z is the general solution for the given linear Diophantine equation. So this is a procedure to find a linear Diophantine equation. This completes the problem. We shall move on to another problem. Solve the linear Diophantine equation of 70x plus 112y which is equal to 168 for all x belongs to z. Here the given equation is of the form ax plus by which is equal to c, where a is 70, b is 112 and c value is 168. Here we have to first find the GCD of a and b. Here a is 70 and b is 112. Here to find the GCD for the two value means we have to divide the greater value with the smaller value. Here we have to divide 112 by 70. Here the quotient is here 70 into 1 is 70. Next step we have to subtract 112 by 70. We get a value as 42. Next, this is a remainder. Next step we have to divide the divisor value with the remainder value. So take like this. Here we have to divide 70 by 42. Next we have to take a quotient value as 1. That is 42 into 1 is 42. We have to subtract 70 by 42. We get a value as 28. This is a remainder value. We have to divide this divisor value with the remainder value. Next step we have to take like this. Here we get 28. Here we have 42. Here the quotient value is 1. Here next step 28 into 1 is 28 itself. So we have to subtract 42 by 28. We get a value as 14. This is a remainder value. Next step we have to divide this divisor value with the remainder value. We get like this, that is 14 into 2. We know that 14 into 2 is 28. So we subtract 28 by 28, we get a value as 0. So 0 is a remainder. So we have to stop the division method here. Therefore we can conclude that the last non-zero remainder, that is 14, is a GCD. That is the GCD of 70 and 112 is 14. Once you obtain the GCD value, we have to verify the given condition, that is D divides C or not holds. That is GCD of 70 and 112 is 14, that is D value. That is D value is 14 and C value is 168. We know that 14 divides 168, that is 168 divided by 14 we get a value as 12. Therefore D divides the whole. Therefore we can conclude that the given equation has a solution. Next step, we have to find the particular solution for the linear Diophantine equation 70x plus 112y which is equal to 168 with the help of division algorithm method. First apply division algorithm method for this fraction, we get as 112 which is equal to 70 into 1 plus 42, or we can take this as 42 which is equal to, take this value to the left hand side, that is 112 minus 70 into 1. Call this as equation number 1. Next we have to apply division algorithm method for this value, that is 70 which is equal to 42 into 1 plus 28, or we can take this as 28 which is equal to 70 minus 42 into 1. Call this as equation number 2. Next step, apply division algorithm method for this fraction, we get as 42 which is equal to 28 into 1 plus 14, or we can take this as 14 is equal to 42 minus 28 into 1. Call this as equation number 3. Here no need to take division algorithm method for this value because the remainder is 0 here. Next step, take the equation number 3 and continue the procedure. Here from equation 3 we get as, that is equation 3 is 14 is equal to 42 minus 28 into 1. Next step, substituting from equation number 2, here 28 value we have to substitute, we get as 14 is equal to 42 minus, here 28 is nothing but 70 minus 42 into 1 into 1. Here multiply 1 inside the bracket, we get as 42 minus 70 into 1. Here minus to minus plus 42 into 1. Here we have 42 into 1 plus 42 into 1, we get a value as 42 into 2 minus 70 into 1 as it is. Next step, we have to substitute 42 value here from equation number 1, we get as, here 42 is nothing but 112 minus 70 into 1 into 2 as it is minus 70 into 1 as it is. Next step, multiply 2 inside the bracket, we get as 112 into 2 minus 70 into 2 minus 70 into 1. Here we have minus 70 into 2 minus 70 into 1. If we add that value, we get a 14 is equal to 112 into 2 minus 70 into 3. So we get an equation like this. Next step, we have to multiply throughout the equation by one value such that C value same as that of this value. So we have to multiply throughout the equation by 12. We get 14 into 12 as 168. Therefore, if we multiply value, we get as 14 into 12 which is equal to 112 into 2 into 12 minus 70 into 3 into 12. So multiply 12, we get as 14 into 12 is 168. In the right hand side, we have to multiply 12 for this 2 value and we have to multiply 12 for this 3 value, because to achieve an linear Diophantine equation of the form 70x plus 112y which is equal to 168. So if you multiply, we get a value as, here take this value first, that is 70 into, here multiply minus inside the bracket, we get as 12 into 3 as 36, that is 70 into minus 36 plus 112 into, here 2 into 12 is 24. So this is of the form 70x0 plus 112 y0. Therefore, we can conclude that x0 value is minus 36 and y0 value is 24. So this is a particular solution for the given linear Diophantine equation. Once you obtain the particular solution, next you have to find the general solution with the help of the formula, that is x is equal to x0 minus b by dm and y is equal to y0 plus a by dm, where m belongs to z, that is some integer. So substitute x0 value, y0 value, a, b and GCD value here we get as, here x is equal to, here x0 is minus 36 minus b value is 112 divided by GCD value is 14 into m as it is. Similarly, y0 is equal to 24 plus a is 70 divided by GCD value is 14 into m. Next step, we know that 112 divided by 14 is 8. Here 70 divided by 14 is 5. Substituting that value, we get as x is equal to minus 36 minus 8m and y is equal to 24 plus 5m. Therefore, finally we can conclude that x is equal to minus 8m minus 36 and y is equal to 5m plus 24 for all m belongs to z is the general solution for the given linear Diophantine equation. So this is a procedure to find the solution, that is general solution for a linear Diophantine equation. The procedure is same for all the problems. This is very important step is, here we are multiplying throughout the equation by some value so that that value is same as that of the given equation C value. That is the very important step here. So till here we studied definition, theorems and problems on linear Diophantine equation with the help of Euclid's algorithm. That is, with the help of finding greatest common divisor and division algorithm method, we are finding the solution for a linear Diophantine equation. In next video, we study about congruences. If you have any doubts regarding this topic, comment below. Thank you.